Welcome to Linux Fundamentals Part 2, the TryHackMe walkthrough and study guide. We are going to be learning some more Linux today, and I hope you enjoy your time. Let's get into it. So this reads right here, we're going to continue the journey. We're going through SSH, how to advance our commands, and file system interaction. Awesome. If you haven't already, go down to task 2 and start your machine. I've already got mine started. So I try and add 1 hour just to double up, get as close to 2 hours as we can. You can only add an hour once you've gone below 1 hour. Anyway, so your IP address should show up in the next 10 seconds or so. While we wait for that, let's just quickly go over the intro. It says, welcome back, cool. In part 2, we're ditching the in-browser functionality. So if you followed along with mine last time, we already did ditch it. So it's a fundamental skill being able to log into control terminals remotely. So like I said, it's what we've started doing. So unlocking the potential of a few commands, introducing flags and arguments, something we did touch on last video, and going into the file system, new mechanics for keeping files and folders secure. So this is something that I definitely want to improve on, running our first few scripts and executables. So I actually want to show you how to speed up the process of SSHing with a bin bash script. So awesome. So this is talking about SSH. So that's task 1 done, by the way. So task 2, accessing your Linux machine using SSH deploy. So SSH is secure shell socket. So we can see here it's a form of connecting. So I like to think about it is we're also logging in over the user, over this connection. So we're not just connecting, but we're logging in as another user. So there's a little bit of a difference here. So it allows us to remotely execute commands on another device remotely. So it's really powerful. Any data will be sent between these devices encrypted when it's sent over a network such as the internet, which is what we're doing. So the detailed instructions for your IP address, yours is going to be different to mine, are in here, how to start your attack box and all of that. What's handy is here, what I figured out in the last video was how to SSH into it using the IP and the user. So there is that default user of TryHackMe and the password being TryHackMe also. So let's go ahead and do that. First of all, we need to access it. We need to use the VPN to get into the network. So if you haven't done that, download your configuration file and connect. So we need to run sudo open VPN, and we need to go to where we've saved that configuration file. Now, I'm just going to show you a little something or other. So I've gone ahead and planned out this TryHackMe open VPN. So let me just cat that out and show you what it is. So this is a bash script, so just a simple bash script where we can automate the process. So instead of typing in this command sudo open VPN and the file extension, as long as we don't move that file somewhere else, this will work. So the only thing that you need to do is this pound exclamation mark bin bash. So that's going to tell the file that to run this as a script. Once you do that, so I'll take you through the process. So let me clear that out and we'll do another one. So let's go and use Nano, so it's a text editor. I'll just create a second one here, TryHackMe open VPN, and we'll just call it 2, open VPN 2. Cool, so we're going to create that. So we go pound exclamation mark bin/bash, and then we type in our commands as if we were writing it into the terminal ourselves. Instead, we're just going to save it as a file. There's one other step that I'll show you. So let's just do this. So we're going to go sudo open VPN. So again, just running that command. So we still need to write out the full file path to get to it. C uses your username, not my username. And I've still left mine in the downloads, and then the file is my username, open VPN. Great. So we can hit Control X, we can hit Y to save that off, and we can go yes. So ls, and now we've saved off that file. So to make sure that everything is there, we can cat it out and we can see it's there. Now you might have noticed that there's a little bit of a difference where my other one was green, so that means it's executable. So if you go ls dash L in this environment, we can see here 1 is green and it has these X's, whereas 1 is not green, what we just created, and it does not have the X's. So that stands for executable, meaning we can't actually run it. So we just need to run another command called chmod, change mod, or change user mod, something like that. And we just need to go plus X. So we're going to plus that X, that executable feature, to TryHackMe 2. So now if you ls-l, we have that X there and we can run it, which is quite cool. So in order to run that bash script that we just created, we just hit the current folder that we're in, and then we just tell it to look at that folder that we just created. So that's going to run it as if we've typed those commands ourselves. It's going to prompt us for our password, and if I type it incorrectly, it's going to run that. It's going to initialize sequence completed, and we can go verify that we have completed the connection and we got our successful connection over the VPN. So seems like a little bit of work the first time you run a bash script, but you think about it, you never have to write that that command again to connect to TryHackMe. It'll just automatically connect you. So that's task 2 done, plus a little bit of extra, so cool. Now we're going to task 3, introduction to flags and switches. So let's read this out together and let's see what we've got. So a majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. So last video I sort of likened switches to like options or settings that you can configure your programs, which is quite cool. We'll later discuss how we can identify what commands allow for arguments to be provided, understanding what these do exactly. When using a command, unless otherwise specified, it will be performed by its default behavior. So something that we always use to run as like an admin or the root is sudo. That's actually not what sudo is for, but the default behavior runs it as root. So a little bit of an interesting tidbit there. So ls lists the contents of the working directory, however the hidden folders are not shown. So we can see our A, which is something that I used last video also, so if you haven't seen that, go back and watch it. So this is still in the my directory, by the way. I need to actually log in to the box, so I failed to do that. So let's just SSH into the box there, which is TryHackMe, and then your IP address, which is up on the top there. So that'll just say, hey, do you want to do this? It'll ask you for a password, and the default is TryHackMe. Whoops, that is an important part of task 2. My bad. Continuing task 3. Once we are in here, now we can ls a, and we can see that we've got some different files. I always like to do LA, so that's going to put it in a list, and you see some more information about read and write and executability. So these are like permissions, which is a little bit more advanced that you'll see soon. So next thing is we've always got a help. So any command has usually got a help. So usually it's dash help, or it's -h, something along those lines, and you can usually get your help page or your help information. So it doesn't show as a page, it shows just the information. So you can see here all the different switches. Now it's super overwhelming at first. You've got lowercase switches, you've got uppercase switches. Sometimes they do similar things, sometimes they do completely different things. Don't get overwhelmed with switches. Like basically you'll need to figure them out, and you just need to know where to go to figure it out, if that makes sense. So don't get too worried about memorizing it. Honestly, I don't memorize much. I've got a shocking memory, so yeah, if I can do it, you can do it. The next thing is a manual page. So the man command is its own program. So if the developers of the other programs like ls create a man page, then there should be a man page or a manual that is in there. So this opens up in a slightly, it doesn't just print out to the terminal, it sort of opens up in its own thing. So you can use the up and down arrow keys to actually cycle through, which usually cycles through your commands that you've previously done. And then you just hit Q to cancel out of that man page. So that's kind of interesting. Most programs or commands have got man pages, so you can go through there. So explore the manual page for the ls command. So like we were just doing, man ls to get in there, and you can just continue scrolling through. And what directional arrow key would we use to navigate down the manual page? Like I was just doing, would do down. Whoops, accidentally put it left. Still worked. Cool. What flag would we use to display the output in a human readable way? Interesting. So if we look through our, we have to sort of, and we have to go one after the other, and that might take a while. I feel like I'm pretty close, but that might take a while to get through that. And that's okay. So we can just keep looking and what's that? Human readable, that was something. So I think it's this H. So that's one way we can siphon through this information. I want to show you a quick other way. It's a little bit more advanced, but it's kind of hopefully seems a little bit exciting. So if we actually ls-help, so we're going to display all that to the terminal. And if we do something called piping, so do this, do that character, I don't actually know the exact name, but I think it might just be a pipe, I don't know. So if you do that character, and then we're going to run it through a search pattern program that we learned in the last video, in the last fundamentals, number 1, and we're going to look for anything that has human in it and see what we get. How cool is that? So instead of just showing us the whole help page, grep searched through to find the word human, the pattern of characters human, and then only displayed that line for us. So that's a nice way, or instead of manually searching through, which we found, which didn't take that long, but you can imagine if there's a lot of data that you've got to search through, this is a nice way of starting to search through other commands. And how it's kind of easy once you start to know the programs and the commands you can start putting together. So that's kind of cool. So we can put -H in there. So that completes task 3. So we can move on to task 4, which is file system interaction continued. Cool. So we covered some of the most fundamental commands when interacting with a file system, like ls and find. Did we do find? Did I skip over it? Or no, we're about to learn about. Oh, we did find. Yeah, sorry. Back in the other one. Yeah. I'm with you. And we're going to learn some other commands: create files and folders, move files and folders, and delete files and folders. So we got a few. We got touch. We got make directory, which, as the name sounds like, make a folder, make a directory. CP for copy, MV for move, RM for remove file, determines the file type. So this is quite cool. So if we list out our directory, we can also determine what is a file and what isn't a file. One, by the color coordination. So white is just directories in this shell. Blue is directory. We can also tell by the letter D here at the beginning telling us it's a directory. The dash mean it's not a directory, mean it's a file. So everything's a file, even though it's a directory, it still is a type of file. But in this case, there's a clear difference here, just for learning's sake. So we can do a few things. So we can, if we go through here, so creating files and folders, so we got touch. So let's try that. So touch note. So that's weird. It looks like it didn't do anything, but if you run the ls -l rather, we do have that note. We've just created that note, which didn't exist before. So that's kind of cool. So if we cat out what we just created, again, we don't get anything back because we haven't put anything in it. mkdir, make directory. We can get my directory. ls-l will create that. And there is my directory. So we created my file, my dir. Cool. So that's really cool. Removing files and folders. So we can delete essentially by using the rm for remove, and we just go rm and my file. So if you hit tab a couple times, it'll show you do you want to remove my directory? Do you want to remove my folder? What do you want to do? Let's go for my file. doesn't show us anything. Does it work? Well, we can hit ls or ls-l and to see, yeah, it's gone. Bye bye. Cool. So we have a switch here that it says R. So provide the R alongside the name of the directory you wish to remove. Extraordinary command so far was simply by, yeah. So if you're ever unsure, like, oh, what is that? Remember, we can just look up the manual page for any program. So RM is just a program, so we can look up manual page and we can manually search through for that capital R, which lowercase r, uppercase R, or dash dash recursive here means remove directories and their contents recursively, so anything inside of them. So you want to get rid of that directory and everything inside it, then we can do that. So let's do that towards my directory, and we can list out, and it's gone. And anything that we moved or put into it would have been gone too. So copying and moving files and folders, CP and MV. So starting with CP, this command takes two arguments, the name of the existing file and then the name we wish to assign to the new file we are copying. Yeah, interesting. So let's just make a note. Oh, we've already got note. So we've got note. Let's just copy note and follow along. There we go, note to note 2, we ls, and we've copied the contents. How about we actually nano into note, and we'll actually put my notes by me, control X, Y, and then enter. So if we cat out note, then it's definitely, that's unique, that's my notes. If we copy note over to note 2 again, replace note 2 that was empty, and then we cat out note 2, we will see the exact same. So we have made an exact copy, which is kind of cool. Moving a file takes two arguments. Just like a CP command, however, rather than copying and or creating a new file, MV will merge or modify the second file and will provide as an argument. So it's a little bit different. So we can move note 2 to note 3, and let's cat out note 3. It'll be the same, but we've essentially made we've moved it. So if you go ls, you'll notice that there's no more note 2. So we've not just moved it over. It's sort of like cut versus just copying. We haven't made a copy, we've cut it, and then we've pasted it somewhere else, and we've removed that original. So yeah, think of MV more like cut, what we're probably more familiar with in like a Windows environment in that. Determining file type. So file is the last command, and file's pretty easy. You just run file against a directory, or a file. The word I'm thinking of is file. The command is also file. So interestingly, if we just run that against like a directory, it'll say it's a directory. So it's telling you the type of thing that it is. Directories are still files, as weird as that might seem. Yeah, so we see that it's just plain text in ASCII, which is something we can look up and talk about another time. Awesome. So let's go through our task 4 questions. So we've got, how would you create the file named new note? So going over ours, we've got, remember touch was going to be that. So we go touch new note, and we got that one. Awesome. So we can try that out. It's always a good practice to try out, not just get it, but actually put it in the terminal and try it out. So if we ls, we definitely have that new note. Awesome. On the deploy machine, what file type is unknown 1? So we've got this unknown 1. So, ooh, what is it? Remember, run file against the file that we want to find out the file type. So in this case, it's just a clean ASCII text2. So we'll save that for a sec. How would we move my file to the directory my folder? So let's try this out. So do we use rm? What do we use? So remember, we have a mv for moving. So remember, like cutting, we want to cut. So if we want to cut and extract my file over into, did I delete it? I deleted it. Let's just go ahead and create my file again. So if we want to move my file to my folder, we go ahead and do that, and it's gone in that directory. So if we just list out what is in my folder, we can see that my file has gone over there. So exactly like, you know, a normal file system and file explorer in Windows environment. So we can just copy that over, chuck that in. Awesome, so we got that one. And next, what are the contents of this file, of my file that I deleted and I got rid of? I'll be right back. So yeah, it's th file system. So I accidentally got rid of my file. So I couldn't complete that. Just had to yeah. Whoops. My bad. But I remember from last time I did this, th file system. Don't delete the wrong things. So yeah, I'm sure that there's probably a correct way that I could have like SSH and gone back in that, but anyway, I found it. Awesome. So task 5 now, we're on permissions 101. So this is introducing a switch that I've used a couple times here for this ls-l. So super important to see these permissions on the left of your terminal. So it seems really confusing at first. It's just a bunch of R's, W's, and X's, and then just a bunch of names repeated. So it doesn't make much sense. So let's go through, let's try and make a little bit of sense of it and work this out together. So as you've already found out by now, certain users cannot access certain files and folders. We previously explored some commands that can be used to determine what access we have and where it leads us. So in our previous tasks, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command when we use this -l. And we get the screenshot of the same sort of thing. So the 3 characteristics here are read, write, and execute. So read with an R, write with a W, and execute with an X. So read meaning we can see the thing, write means we can actually interact with it, X means we can also interact with it. Yeah, there's a little bit of a difference. Let's see what we got. Let us use the, so we've got a PM file here, an initial screenshot at the top of the task. So indicating, highlighting that it is a file, so that's this first character here, and then starting with the RW, meaning read write access, followed after. This means that only the owner of the file can read and write to this file, but cannot execute it. It means we can't run the file. We might be able to change the context, but we can't run it. So we briefly explored this Linux fundamentals part, namely the differences between regular users and a system user. So we can switch between users, which is quite cool. So let's put it into real world context. So the system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will want to allow their users to upload their own files to the website without being the web server system user. Okay, so it's a fundamental security concept of authentication, who you are and the abilities then you have. So yeah, really important. Switching between users, so we've got the su command. So su, and I also sudo is sudo, however you want to pronounce it. So we can use the su command, take a couple of switches that may be relevant for us. For example, executing a command once you log in, or specifying a specific shell to use. I encourage you to read the man page for su to find out more. Okay, we'll do that. We'll cover L and login switch. Simply by providing the -L switch to su, we can start a shell in a much more similar to the actual user logging in to the system. We inherit a lot more properties of the new user, i.e. environment variables. So let's go ahead and try this. So su user2. Password, do we have a password? I'm gonna say it's the same. Yeah, cool. So we have swapped users. So if we go and LSA, like we see the same things again, but we now can actually like see this as a different user. So it's kind of cool. So we could su back to TryHackMe, and then we could use the password again, and we can change users. So nice way of changing users. For example, when we want to use su to switch to user 2, in a new session drops us previous home directories, so you can use that -L. Cool. So on the deployable machine, who is the owner of important? So we can see here that it actually is the user that we can also log into as user 2. What would the command be? To switch the user to user 2. So as we just did, su user 2. Awesome. Now the switch to this user using the password user 2. We just did that. So if we go back up, that was a different user, so we'll just go su user 2, try and spell it right, user 2, nice. Output the components of important. Okay, so we will cat out important, and we will see our flag here. Awesome. Good stuff. Killing it. Absolutely killing it. So second last task here, so task 6, common directories. So this is really cool. So let's just su back into TryHackMe again. And that is TryHackMe as the password. Nice. So if we ls-l the root directory, like we did in our part 1, we can see all of the directories. So this is the top most high level folder. So we've got a couple here that TryHackMe are going to bring to our attention. So we've got etc. So I always think of like etc. et, even though I think that's like ect. I don't know. The root directory is one of the most important root directories on your system. So that's just what we looked at. The ECT folder, short for etc. It is etc. etc. Is a commonplace location to store system files that are used by your operating system. So sort of like the Windows folder in Windows that's dedicated to the OS, along other things. For example, the sudo is file highlighted in the screenshot below is a list of users and groups that have permissions to run sudo or a set of commands as the root user. Interesting. So let's try that. We'll ls the etc folder. Cool. Cool. Also highlighted below are the password and shadow files for these two files, special for Linux. So very, very interesting. Next is the var, so the var directory with var being short for variable data. It's one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on your system. For example, log files are running services, applications, and are written to var-log. Cool. On other data that is not necessarily associated with a specific user, databases and such. I'll speed through the last couple. So root is the root, which is actually a user. They also have their own directory. So that's the top level user. So everybody has a root running on their system. TMP is for temporary, and this works similar to RAM or memory on your computer, which is volatile, meaning it will be removed, deleted, gone skis when your system shuts down and starts back up. So it's it gets wiped. So the temporary file does the same sort of thing. So if you're just mucking around like with test files and stuff, you can put it in temporary and you just know that it'll be gone. So don't put anything important in there. Awesome. So let's read that. What is the directory path that would be expected for the logs to be stored in? So we did see that back up here. So var logs. So let's go and where are we right now? So we're in our home folder. So let's just go over to var/log and list out everything that is in here. So we have different things for like Apache and system logs, authentication logs, kernel logs, and that sort of thing. So yeah, lots to go through. That's pretty cool. So we can just put in var/log. What root directory is similar to how RAM on a computer works? So that last one there, temporary. So let's go over to that one too. So cd -temp, and we've got some temporary files that I guess did. I don't know how they got there. Yeah, interesting. What root directory? Yep. So that is tmp/one we did. Name the home directory of the root user. So if we go back to our directory, remember that this root is both the root user and then the root folder. So will we be able to go there? So we're not there. So we'll just go change directories into root. Yeah? No, dang it. We don't have root permissions. We can't go to that sort of thing. So there are permissions. And we also could have found that out if we went ls-l on the root. We could see root. We don't have any access to see it. Yeah. Awesome. So name the home directory of the root user. So that was root. And cool. Now apply the learning. So we've gone through and we've done that. So we can tick that off. So well done. That concludes our part 2. So it goes through here and just says nice work. Thank you very much. And then part 8 is showing us over to part 3. So that's task 7 and 8. And well done. Congratulations. You have successfully been walked through Linux Fundamentals Part 2. I hope you got something from this. Go back and watch Linux Fundamentals Part 1 if you want to recap. Skip around on the chapters to anything that you need. I hope you've learned something, and I will see you in the next one. Thank you.